Yeah, next topic is alkalinity. In your textbook, there is no alkalinity concept, but acidity. But actually, alkalinity is more commonly used, this term in chemistry, especially in environmental chemistry. People they measure this alkalinity of water, okay, of natural water, okay, and so so I decided to explain the alkalinity rather than acidity, okay. And first of all, you have to differentiate the alkalinity from basicity, okay. Basicity is what? That simply says pH, okay, in terms of hydroxide ion concentration, okay. So the basicity or acidity, they are all, you know they don't depend on the volume, okay. They don't depend on the amount of solution, okay. You understand? For example, now you have a pH 5 solution, okay, and no matter how much you take the solution, the pH, or acidity or basicity is the same, okay. You don't need to take 1 liter the solution to measure pH. You need very little solution, yeah, maybe 1 milliliter to measure pH, right? So pH is what? Intensive property. You know the intensive and extensive property. Intensive property doesn't depend on the quantity, okay, but extensive property depends on quantity, okay. Acidity or basicity are intangible properties, okay. But here alkalinity is extensible property, okay. Extensible property. Why? Alkalinity depends on the amount of the sample, okay. So if you take more sample, and then alkalinity increases in proportional to your the quantity, okay. Okay, here okay, here's the definition of alkalinity. Alkalinity is the moles of hydrochloric acid equivalent to the excess moles of basic species in the sample to reach pH 4.5. Wow, this definition makes you confused, all right? But don't worry, okay? I'll explain. Yeah? Alkalinity actually is the HCl equivalence, yeah? Because we simply assume that the solution takes that's the it contains alkaline species like hydroxide ion and carbonate and bicarbonate, yeah. So natural water, yeah, natural waters contains mostly these three species, okay, hydroxide, carbonate, and bicarbonate, because the CO2 in air now dissolves in water, so it takes these two forms, okay, yeah. So to neutralize these three species, you need the acid, yeah? In this case, strong acid, okay, HCl, yeah? And here, moles of HCl needed to bring 1 kilogram of water to pH 4.5, yeah, okay. Yeah, this is definition, okay. You take 1 kilogram of water, which is 1 liter approximately, okay. Here, so alkalinity is this one. You the sum of hydroxide ion concentration, okay. Why? Um, the hydroxide ion and HCl proton react 1 to 1, okay. And you add the carbonate ion, but you have to multiply by 2. Why? Because this carbonate ion takes 2 protons, okay. So one ion of carbonate is equivalent to what? 2 protons, okay. And then this bicarbonate maybe acts as both as acid or base. But since here uh, we take this one as base, okay? So proton, one proton reacts with the one bicarbonate ion, okay? So this alkalinity, this is definition, all right? Yeah. So this alkalinity concept is very important in water treatment and chemistry and biology of natural water, okay? I have learned several years environmental chemistry when I was in chemistry department. Yeah, so I found that this alkalinity concept is really important in environmental chemistry. Okay, but very unfortunately, our textbook has quantitative chemical analysis, eighth edition only shows acidity, but the ninth edition shows this alkalinity concept. Okay, and I uh, mm, recommend you to to differentiate the extensive property and intensive property. Okay, yeah, pH is intensive property, but this alkalinity is extensive property. Okay, depending on the quantity of sample, right? So if you increase the sample 2 kilograms, and then alkalinity increases 2 times, okay, in proportional to the sample. Well, here is example. Natural water typically has an alkalinity of 10 to minus 3 equivalents per liter, okay, which is what? Hmm? Equivalence is what? HCl equivalent, okay. Now, question is calculate contributions of different species to alkalinity at pH 7 and pH 10. Okay, this says this one. Uh, what's the alkalinity at pH 7 and what's the alkalinity at pH 10? Okay, let's consider the first at pH 7. Okay, yeah, this is the fraction of CO2 when it is dissolved in water. Okay, and when it is dissolved in water, it exists as these three different forms: carbonic acid, okay, or maybe CO2. This carbonic acid is equivalent to CO2, okay, and bicarbonate and carbonate, okay. At pH 7, hydroxide ion concentration is 10 to minus 7 molar, okay, and you see at the pH 7 here, this bicarbonate concentration is much greater than this carbonate here. So we ignore this this term, all right? And we simply we have only this one equation. Okay, CO2 reacts with water to produce protons and this bicarbonate. Yeah? And for this one, this reaction, uh, the equilibrium constant K1 is already been calculated. Okay, this K1 is given by this equation, and it is 4.45 times 10 to minus 7. Okay, a small value, and CO2 here, yeah, concentration in aqueous, okay, is given by this one, and then it is calculated from this one. pH already known, 10 to minus 7, and K1 is already known, and this one. Bicarbonate here, uh, this is what? This is, let me see, yeah, already uh, here, this is very, let me see, small compared to bicarbonate, and since alkalinity of natural water is known, and then we simply take this value as bicarbonate concentration, all right, comparing this what hydroxide ion, yeah, this one is much greater, right? And then CO2 concentration at pH 7 is about 2.25 times 10 to minus 4 molar, all right? Yeah. Okay, and then let's consider at pH 10. Okay, this is the same, the graph. And pH 10 alkalinity by definition is given by this equation, and this is already given 1.00 times 10 to minus 3, and here at pH 10 hydroxide ion concentration is cannot be neglected, right? This is 1 times 10 to minus 4 molar, okay? And from K2, okay, look at that, at pH 10, this one, carbonic acid form is negligible, okay? So we only consider this bicarbonate and carbonate, okay? The equilibrium is given by this equation, and K2 is already known, right? This is known. People already, they obtained this K2, and 4.69 times 10 to minus 11, right? Yeah. And here, the carbonate concentration, yeah, is given by this equation. Okay, this is what? Proton concentration already given because the pH is fixed, and K2 is given here. And what is the bicarbonate concentration? Yeah? Bicarbonate concentration, let me see. Here we could calculate. Let me see. From let's see. Here alkalinity already given right here, which minus concentration is here, and we have two unknowns, carbonate and bicarbonate, right? Here also we have two unknowns, two equations and two unknowns. So solving these two equations, we get bicarbonate concentration at pH 7 is 4.64 times 10 to minus 4 molar, and carbonate is 2.18 times 10 to minus 4 molar. All right, yeah, we obtained everything, right? And then we go back, this put this back to this alkalinity equation, right? And then we find it is exactly 10 to minus 3 equivalents per liter, right? This is already, yeah, it is the same as this one. So we found our calculation is exact, okay? Here another example is given here. Influence of alkalinity on CO2 solubility. Okay, why alkalinity is so important in nature, in natural water? Because depending on alkalinity, CO2 solubility is quite different. Okay, quite different. Yeah, and then CO2 solubility is great, and then water, natural water, produce a lot of, a lot of what, a lot of, biomass. Yeah? You see, in water system, yeah, there are many species that do the photosynthesis. Okay, like algae. There are a lot of algae and photosynthetic cyanobacteria. They need CO2, yeah, dissolved in water, yeah, to produce biomass. Okay, so CO2 solubility is really important in natural water, and this CO2 solubility quite depends on the alkalinity. Okay, now the question is to find the CO2 solubility in pure water, and this one, 10 to minus 3 molar sodium hydroxide water. Okay, yeah. So CO2 solubility, when CO2 dissolves in water, it exists as two forms. Okay, first the CO2 dissolved, the CO2 form and bicarbonate form. Here, oh, what about you may ask that, oh, professor, what about this carbonic acid form? Actually, this form doesn't exist at all in water. CO2 simply, binds to water, but actual form is not this carbonic acid, okay? But for the convenience, yeah, people usually write it this way. But actually, in when dissolved in water, CO2 either exists as this one CO2 form, or you can put here H2O, okay, and this one bicarbonate form. All right. So since CO2 exists as these two forms, solubility is some of these two concentrations. Okay. the first, in pure water, alkalinity is a zero. Okay, is zero, almost a zero, and CO2 concentration is given by this value. Okay, this is well known. All right, and let me see. Oh yeah, right. Yeah, the pure water, it is already measured value. Okay, and CO2 now undergoes the this reaction, producing this bicarbonate. Okay, and this one, proton and bicarbonate concentrations are almost the same, and then from K1, and we solve for bicarbonate, and then we get 2.25 times 10 to minus 6. Okay, 6 molar. So solubility of CO2 in pure water, the sum of these two species, and then it is 1.37 times 10 to minus 5 molar. Okay, that's the CO2 solubility. Okay, in pure water. But what about the CO2 solubility in point 10 to minus 3 molar NaOH? Okay, pH is 11, right? And alkalinity is what here? This is hydroxide ion. Is the uh, major species. Okay, so alkalinity is quite depends on the hydroxide ion, and which is 10 to minus 3 equivalents per liter. Okay, and CO2 uptake by hydroxide ion is just we consider this equation. Okay, so solubility again, the sum of these two concentrations. Okay, and CO2 what this solubility is here, same no, number here, and bicarbonate solubility is what? Hmm? This is same as uh, alkalinity, so it is 1.01 times 10 to minus 3 molar. Okay, much higher. Okay, CO2 solubility is much higher at this basic solution than this neutral or acidic solution. Yeah, this implies important things because CO2 solubility is higher, and then using many marine, many the aquatic species like algae or cyanobacteria, takes as the CO2 and use the CO2 for the photosynthesis. Okay, so water biomass productivity increases a lot. Yeah, in this what the basic solution. Okay.